Alright, so this is the point where Algebra 2 students come back and thank me for things. It has to do with putting it all together. Um, I taught you how to complete the square, and now that's going to become useful in graphing this equation. So to graph this, right now you don't have many tools. I suppose you could find the intercepts by factoring it and setting equal to 0. But beyond that, trying to figure out more about it, it's a little tricky. So I'm going to help you put this equation, which is in standard form, into vertex form, we'll call it, to help you identify the vertex of the parabola, and then from there graph the rest of the parabola. So I have y equals x squared plus 6x plus 9. And so I'm going to factor that. Well, actually, I'm going to complete the square. So I'm looking at, remember, to complete the square, I have to take half of b and then square it to get my c value. So half of 6 squared is 9. So this is kind of an interesting case where I don't have to change the c value or move the c value over and then create a new one. I could do that if you'd like to see what that looks like. I'd subtract 9 from both sides, so I get y minus 9 equals x squared plus 6x plus blank. And I'd have a plus blank on the other side, and so I'd add 9 here. 9 minus 9 just gives me y. So actually I didn't need to do that, but if you needed to see that, there it is. So to complete the square, this is x plus 3 squared. And if you'd like to rewrite it to be more explicit, and my a value is 1, x minus my h value, which is negative 3, squared, plus my k value, which is 0. So my vertex here is negative 3, 0, which I will mark on my graph right there. The line of symmetry is my x value of my vertex, which is x equals negative 3. Now to find my y-intercept, there's a couple things. So first, maybe I'll do it more explicitly, and then I'll show you an easier way. So to find the y-intercept, I'll start with my original equation, y equals x plus 3 quantity squared. And I will set x equal to 0, right? Because at the y-intercept, x is 0. At the y-intercept, x is always 0. So y equals 0 plus 3 squared, which is 9. So my y-intercept is 0, 9. Now that might be straightforward from the vertex form, but it's also even more straightforward from standard form. Because when I said x equals 0, that goes to 0, that goes to 0, and I'm left with 9. So in standard form, it's always the c value that determines your y-intercept. However, your x-intercept's a little harder to find here in standard form. You could use the quadratic formula and set y equal to 0. Or you could use your vertex form, y equals x plus 3 squared, set y equal to 0, and solve that way. Since you already have your squared quantity alone here, take the square root of both sides, and so you get 0 equals x plus 3. So what do we do from here? You'd be expecting here to see, two values here, right? But plus and minus 0 is the same as 0. So when we solve, we get x equals negative 3. What's up with that? Well, as you can see, there is only one x-intercept. It's right where the vertex is. So this is a special case where the vertex is right on the x-axis, and therefore there's only one x-intercept. Since I've already found that 9 is my y-intercept, I know that I have a symmetric point right there. But 3 points isn't really enough, but at least helps me understand the direction. And as I recall, my a value was 1. So that means my jump pattern was plus 1 times 1 plus 3 times 1 plus 5 times 1, and so on. So I could go right 1, up 1, left 1, up 1, right 1, up 1, 2, 3, left 1, up 1, 2, 3. And as you can see, I moved my symmetric point, and now I have my parabola. So now I can graph it using completing the square. We will continue more examples of that in the next few openers.